So welcome back. Hope you had a good lunch. My name's Sarah Bentley. I'm Chief Customer Officer here at Severn Trent, and I look after our retail customer-facing teams, but I also look after our network teams that both on the water and the waste side. And the next 40 minutes or so is going to be all about water management. So I know you've had some really, really great sessions so far, but we're going to focus on two things around water management. The first thing we're going to focus on is all the work that we're doing. Come on in and grab a headphone. The first thing that we're going to be doing is focusing on all the work we're doing to improve the network and reduce leakage, because obviously that's critically important in managing water. And the second area that we're going to focus on is all the activity we're doing with our customers to help them become aware of how much water they're using and also how much water is wasted from their homes. Because between these two things, we can really make a big impact in the water in our area. And we're not going to be sat here for all of this. So in a minute, I'm going to get you up and we're going to go out and have a look at some of our teams in action. But before we do that, I just wanted to set a bit of a context as to why we're here and why we're talking about water on an ESG day. Now, it's not lost on me for a minute that it's been very, very wet over the last little while. I also look after the waste networks, and my teams are out running around trying to sort out the flooding from the rivers and just the management of the sheer volume of water. But believe it or not, these pictures were taken from our patch just 18 months ago. And it's sometimes hard to remember that we had the hottest, driest summer for over 40 years. And actually, water is a really critical resource. And I know you've heard about our triple carbon pledge, and obviously carbon is a massively important thing in the fight against climate change. But I think water sometimes gets forgotten. And last year, the United Nations World Water Report said that by 2050, 5 billion people will be living in water-scarce areas. And some of those people are going to be in the UK. Now, we know the problem is much worse in the south, but we do have water-stressed areas of our region too. So it's really important that when we're thinking about ESG, we are a water company and that we put water management right at the heart of that strategy. So the good news is we are a water company and we are doing a lot about it. So we have these 25-year water resource management plans, and that's where we look over 25 years about all the different dynamics, population growth, urban development, but also scenario modeling, and it's lived thousands of different models that look at different scenarios with 2, 3, and 4 degrees global warming. So we can make sure that we're putting the right infrastructure in place and got the right long-term plans to secure water in our area. So we care about it passionately. You've seen our purpose today, which is taking care of one of life's essentials. And that's because it really is the core to our purpose of making sure this very precious resource is not just available for today, but for generations to come. So our teams are working around the clock, and I can't wait to take you out and get you to meet some of them in a minute. So to manage water well, you need to do 4 things brilliantly. The first one is to invest capital wisely. The second is to be brilliant at delivering big capital schemes. The third one is to be able to improve your network and reduce leakage, and as I said, we're going to look at that in a minute. And the fourth one is to work with customers to change their behaviour so that we're all much more water aware. So as I said, we're going to be looking at the last 2 in a minute, but I did just want to touch for a minute on all we're doing in terms of investing capital and planning for those future scenarios with our water resources management plan. We've got brilliant asset strategy and management teams who've been modelling and working out where we need to invest this precious capital to make sure the right parts of our network get the right extra capital injections. But then we've also got a fantastic capital delivery team, and Helen's actually in our group at the moment. And her team have delivered the most incredible programme of work, and you can see some of it here, just the sheer scale of some of the operations that we've been doing. And probably the obvious one when we're thinking about long-term water resilience is the Birmingham Resilience Programme. And I'm very proud to be part of the company at a time where our teams have worked round the clock for 5 years to try and create a second alternative water source for the second largest city in the UK. And this isn't just important for today, but as I said, for generations to come. So we're clearly very good at the first 2 categories of investing our capital wisely and then doing the complex work of, as you can see, just the scale of it, these huge capital programs. But what I really want to focus on is these two areas of what we're doing to improve our network and then get customers to change their behaviours. Now, we've got to look at our own network first. We can't expect customers to think about water if we're not doing the very things we need to reduce leakage. And it's been a difficult couple of years with the beast from the east, with the long hot weather, has put real stretch and stress on our network. And I'm delighted with all the recovery programs that meant that we hit our leakage target last year, which was a phenomenal task from my teams in that area. But then equally as much, all the work that we did through that process to make sure we're set up to hit these bold targets of 15% in the next 5 years and 50% over the next couple of AMPs. And we need to do three things really well. Firstly, operate our network calmly to reduce the likelihood of leaks occurring in the first place. Secondly, we need to find leaks really quickly. Quite often a leak can be going on just as a seep or a weep for up to 80 days before it's visible on the surface. So we need to get there and stop that wasted water the minute it starts to occur. And then the third thing is, once we do know there's a leak, we need to be able to fix it efficiently. And as you'll see a bit later on, that doesn't always mean digging a hole, fixing the pipe and filling the hole back in again. Once we've got credibility in really tackling leakage, then we can help to encourage our customers to think about the water they use. And I'm quite sure all of us are guilty of chucking fresh potable water over our lawns to make them nice and green, or using that same water to clean our cars. There are some parts of the world where that thought is just abhorrent, that we do that with clean drinking water. And we need to get customers to care as passionately about water as we do. And we believe in this so much that we've signed up to some really bold ODIs, and they're supported by our customers because our customers want us to really focus in this area as well. So we've got these 4 ODIs of leakage, per capita consumption, that's the amount of water each person on our patch uses every day, customer education and metering. So in the first two, leakage and per capita consumption, we're signing up to saving 89 megalitres of water over the next 5 years. That's a huge amount of water that we're going to save. And just to put that in context, that's enough water for 300,000 people. So, and that's just by managing leakage better, being more efficient at that, and by helping getting customers to think about their water use. But we want to go much further, so we're thinking much more for the long term. And so with our customer education program, we're going to be educating the next generation, 500,000 children, to think about water in a different way than you and I do. Because I think we'd all say we take it a bit for granted, and we need the next generation to treat it as this precious resource. And then metering is obviously a key thing, more eyes and ears on the network. So we're going to put in at least 500,000 more meters. And this will be a very, very key tool to get our customers to become more conscious of the water they use. So I'm really feeling confident about the plans that we've got over the next while to really manage water wisely in our patch. But we're going beyond that as well, and playing our part on the national stage. I talked about the fact that the South is very water stressed, and I'm going to invite now Bob Steer, who's our Chief Engineer, to talk about some of the work we're doing with other water companies nationally.
Thank you very much, Sarah.
Cheers, Bob.
Good afternoon, everyone. How was lunch? Was it all right? Jolly good. Right, so I'm Bob Steer, I'm our Chief Engineer. I've been here for about 23 years, and I'm going to talk about some of our strategic water resources schemes. So, as Sarah said, obviously we've got big populations in the southeast, and not all rain falls in the southeast. It largely falls up in the northwest, as we know, around Manchester, etc. So this is about us doing our bit in the middle of the country to see what can we do to help connect up those that have a lot of water and those that need it. So that's what this is all about. And in fact, it wasn't just us that said this. The National Infrastructure Commission, back in 2018, said even when you take in account of people improving their leakage, using metering, reducing their personal consumption, we're still going to be really short in the southeast over the next 30 years or so. In fact, to the tune of about 1,300 megalitres a day, which, to put it in context, is about 6 million people's worth of water. So this is all about our role in thinking about what strategic options are there to get water from the northwest to the southeast. Now, the good news is, because I like a bit of good news, the good news is that if you think about some countries that are water stressed, like Australia had the millennium drought, obviously the geography involved there means that large-scale transfer schemes just aren't practical. As opposed to in England, obviously we've got, we like to think we're a big country, but the truth is we aren't really very big. So some of the connections we think, for us, are quite big pipes, but in the overall scheme of things aren't. So we'll talk about a bit more detail of those. Now then, back in 2011, one of our colleagues Tony Balance started to publish some documents called the Changing Course documents. And that set out in 2011 that we felt we could play a really key role in transferring water, because we thought that might be a better solution than building more resources down in the southeast, such as desalination or more reservoirs, for example. In 2016 to 2018, we firmed those plans up and we put them into our PR19 process, which you'll have all heard about. And we're delighted to say that Ofwat agreed with the fact that we should be looking at those schemes, and they promoted across the companies a basket of £469 million just to do the feasibility work to say, of that basket of schemes, what's the very best way that you can create 1,300 megalitres more in the southeast? So that's the task. We've got £43 million of that to look at look at feasibility. So that's not to build anything, that's to do the feasibility work, because there's a lot of environmental considerations to put in place. And at the same time, this year, of course, you'll have heard about we delivered the Birmingham Resilience Programme. So that means we've got good confidence that we're pretty good at this big transfer stuff. We've delivered the biggest scheme that I've ever been involved with, for example. So in 2020, a group of regulators called RAPID have been formed, and they're going to start to look in 5 years' time at what is the very best way to achieve the outcome of more water in the southeast. And for us in Severn Trent, we've got two main options. We've got the Grand Union Canal Scheme, which is how do we actually use the system of canals that already exist to transfer water from the northwest to the southeast. And we've also got the Severn to Thames Transfer Scheme, which is how do we get a bit more water down the River Severn so that we can pump it across to the River Thames so that London can use it. And that's the one I'm going to talk a bit more about now. So then, we've got a map. It's a very high-tech map. So to start with, so the name of the game is, we can see that we've got the River Severn travels down here. And I suppose the thing to keep in your mind is, by the time you get down to Gloucester, that fresh water in the river effectively goes out to sea. So what we've got to think about is every drop that goes out that way, is there a better use for that somewhere else? So the name of the game for this scheme is how to put an extra 300 megalitres of water in the River Severn so that in times when they need it, they can take it from down in Deerhurst, pipe it across to Culham, down the River Thames and use it in London. So that's fundamentally what the scheme's trying to do. And the way it's trying to do that, I've got a totaliser. So we need to get to a magic 300 megalitres. So, to go back then, sorry, the first bit is Liverpool and Manchester, right up at the top of the catchment. It's not actually in our patch, it's in United Utilities patch. They currently get their water from a big reservoir called Vyrnwy. And what we've worked out is if they could develop some more sources locally, then we could use the water from Vyrnwy and actually get it into the River Severn to start our journey. And that gives us a little bit on our totaliser. In fact, there's a totaliser gone missing. It goes up to 180 megalitres. So, in fact, there it is. I knew we had a totaliser somewhere. So I had faith in you all along. It's okay. Right, so 180 megalitres. So that means we can get 180 megalitres more flowing down the River Severn. The next thing is we pass past Shrewsbury in the middle of our patch. Now, Shrewsbury's got a water treatment plant that if we can develop some sources around it, we can avoid abstracting 15 megalitres of water. So that's an extra bit that can travel down the River Severn. So there you go. That adds to our totaliser, gets us up to 195 meg. Now, by the time we get down to Gloucester, right down towards the Severn Estuary, we've got a sewage treatment works called Netheridge. Now, Netheridge produces a wonderful effluent, and if we've worked out if we can treat it to a slightly better standard, we can pump it back up the River Severn a bit. So rather than go out to sea, we can then use it to go across to London. So that's the next bit. And then finally, the big one, if you like, is Birmingham's got a very large sewage treatment works called Minworth, which treats all of Birmingham's wastewater. And we've worked out that if we can treat that to a high standard, we can actually put it into the River Avon, which in turn flows down the river into the River Severn down there. So if we do all of those things, we actually get to our target. In fact, we get a bit above our target of 300 megalitres per day. And so then obviously the last job then is we need to build the big pipe that connects the River Severn to the River Thames. That's 87 kilometres. So it's obviously a big pipe. It has to pump it quite a long way uphill. And then that will give water to the people of London. So that makes sense so far, hopefully. But along the way, of course, there's a few things that we've noticed. So if you go back in history, often water treatment works were generated around local areas, local towns, local authorities. And if you look in this area here, for example, we've got a big water treatment works in Gloucester, we've got a big one in Tewkesbury, and we're going to have some assets in Deerhurst. So it's a good opportunity for us to have a look at that actually a bit more holistically and think, are there a better set of assets that can deliver a really great product for the long term for all of our communities, including ours? So we're taking the opportunity along the way. The other thing to notice is that we already do effluent reuse. So, all these towns along the River Severn put effluent in and they're taken out by another town downstream. But we'll be looking much more actively at actually reuse systems for ourselves. So, for example, we may be able to use effluent from Minworth sewage treatment works to put into our Coventry system, as way of an example, to make us more resilient. Right then, so if I go back to the other slides, to recap, before we go on to the really interesting stuff about learning about leakage and what happens in the homes. So we've been championing water trading schemes for a long time. Not because we're definitely sure they're always the right option, but because actually, as a basket of options to get more water into the southeast, they should be compared and contrasted with desalination and big reservoir options. The choices need really careful environmental consideration because whilst clearly it may seem wasteful for water to go out to sea, at the same time we do have to do some pumping, and we want to make sure we don't cross-contaminate the catchments of the River Severn with the River Thames. So there's a lot of work to make sure that we protect against invasive species migration, for example. While we're going down the way, we're looking. These are big, once-in-a-lifetime strategic options. So we're going to be looking at options of how do we make our own communities more resilient along the way. And then lastly, projects like the Birmingham Resilience Project give us real confidence that we're pretty good at this big infrastructure cost. So we've got some really good ideas of how we do these things efficiently. So that's all I was going to say on the big transfer stuff. Hopefully that made some sense. We're now going to hand you back to Sarah.
Great, Bob, thanks very much. Yeah, really good. Right, it's time to see some of our teams in action. As I said, to focus on those two areas of how we improve the network and how we get our customers to change their behaviour. So
welcome to the customer house that I'm standing in front of. My name's Steve Witter. I'm head of the customer leakage operations for Severn Trent Water. It's been my 30th year this year, so I joined as an apprentice. So I've worked in all kinds of areas for Severn Trent, but particular passion is distribution and leakage, which is quite lucky because I am the head of leakage. So it's a kind of the job that I designed and wanted, so I'm particularly enjoying doing that. After last year's difficulties of the year before with the freeze thaw and the hot weather, it was extremely challenging, but extremely rewarding now to see some of the strategies, the implementation of an organisational design, which you will hear a little bit about next door, is now really bearing fruit. So, what am I here to talk to you about this morning? Well, in terms of water scarcity, I'm sure you've seen already in the introduction, it's quite a challenge for all of us, globally, nationally and locally. So for Severn Trent, we've engineered a number of ODIs which are interlinked and overlapping almost. And the reality is, it's all about conserving water. So next door, you're going to hear a slot around my job, basically, leakage on the Severn Trent network. And that's next door is around 62 megalitres. But in here, what I want to talk to you about is how we can actually influence customers to use less water. It's with some really easy tips and techniques, and how we can get them to do almost as big a contribution as the 62 megalitres next door for finding and fixing, digging in the highway, as opposed to giving advice. So how are we going to do that? Well, one of the ODIs that we have designed is called per capita consumption. We refer to that as PCC. And that's the amount of water that customers typically will use in their daily lives. So, hence standing in front of the house, I'm sure you could spot appliances that use water and can use differing amounts of water. So the 36 megalitres is going to come broadly in a number of ways, underpinned by customer education. We know this works because we've been doing this in AMP6, and it's been very successful. And we know educating customers and allowing them to understand what they use, how it compares to family and friends and averages, and also the impact it can have on, if you think about electricity, for example, if you're saving hot water, you're saving twice, because you're heating that water, which is also going to waste. And so it's a bit broader. The savings are broader than just a specific water use. So we actually go out and we engage customers on the doorstep. We go into their homes and we talk to them about what they have, how many showers they have, how many toilets they have, and then we offer them water-saving tips, but also free and subsidised devices, which we know the economics mean cheaper for us to save water in the home rather than abstract it, treat it, pump it, and it go literally down the drain. How much do customers use then? Well, it's around 130 litres per head per day. That is what's used. And amazing to me when I first heard the fact, only 2% of that's actually consumed. The rest of that is used for other purposes, washing the car, etc. So quite small amounts. So the final piece in the jigsaw then is metering. in AM7 we're going to fit 500,000 metres, and those metres are going to be fitted at the boundary of the property, and that's quite crucial because one of the big savings, the bottom box in pink is 15 megalitres, and that 15 megalitres is shown will come from what we call burst on private pipes, which we'll explain a bit later on. But that's a key point. If the meter's not at the boundary, you can't identify that. So 50 megalitres, that's the amount we've got to try to save by influencing customers' behaviours. That's about 20 full Olympic-sized swimming pools. So not a small amount of water, but we've got some great experience and track record, and we've got some absolutely brilliant plans. So I'm going to welcome on stage, firstly Nerja, and then secondly Rose, who are going to talk to you about, with my help, some of the details of those plans. Nerja.
Thank you very much, Steve. Hello everyone, I'm Nerja Pandya, and I'm currently working in Severn Trent as a water networks lead. So the job I do effectively is to look at across the entire water programme and then decide which strategy, which activities we should do across the entire ODI programme, but also look at asset health and the wider metrics we're looking at. Now this piece of work in terms of the PCC work that we're looking at per capita consumption, it's got me really excited. And two key reasons why it's got me excited. One is that effectively when you're working in customers' homes and we start to save water in customers' homes, what that means is a real win-win for everyone. So what that means effectively is if you're using less water, you start to extract less water. If you extract less water, you're then treating less water, so less chemicals and less energy. And then across the board, what that also then means is it's brilliant for the environment, but it also means lower bills for customers. And overall, from a Severn Trent perspective, it makes perfect business sense. So in terms of kind of that entirety of that water cycle, this gets me really, really excited. Now the trick to doing something like this when you're talking to customers and you're harnessing their power and their energy is to make it really simple. It's got to be something that can go within their day-to-day life, and it's almost effortless in terms of how they operate. So let's just get into our water savvy house and see how this could actually work in practice. So, as Steve said earlier, customers normally use about 130 litres per head per day. Majority of the water tends to get used in the toilets. It's about a third that gets used in the toilets. A lot of that water is flushed down the toilet. So let's start with the toilet itself. Now, as we've been changing kind of technologies and ways, different flushing techniques, what we found is that the valve flush toilet has become quite popular these days. And when you look at the studies, some of the studies that the Environment Agency has done or the other NGOs have done, what we find in our region is about 5 to 8% toilets are leaking. Now 5 to 8% in simple terms would be equal to about 240 litres per head per day. So it's almost like having 2 extra people in your house using that water every day. So clearly this is something you want to go after. And actually, when you really drill down to it, it's quite simple. So I'm going to let Steve do a little bit of, what are the things we need to look out for and how can we kind of rectify those things?
And I think simple is the key word here. So the reality is, I think it can be seen quite difficult if your target is to try to influence people to make a change or do something different, go out of their way, even spend money or expend effort. But once you realise how simple some of these things are, I believe, that's what gives me the confidence that we can hit these numbers. So, for any of you that have ever fitted or been in the back of your toilet system, in the old days the system would be almost double the size of this and would tend to have an old ballcock style floating ball with an overflow pipe that would go out of the wall. And you might see those either on your own property or neighbours, dripping or running down the wall, big green patch potentially, or damp patch on the floor. It doesn't seem a lot, but when you realise some of these adding up, and when you talk about an extra 2 people in your house, that type of use is quite astonishing, I think. So modern day flush, instead of having the ball cock, you get one of these called an eco flush. But the design flaw with these, and this is worldwide, is that the washer on the bottom gets a little bit, and if there's a few nods in the audience, so there's some experience here already, the washers can be replaced very easily and very cheaply, and equally can be run under warm water, and you can fit them back on and stop that leak. If that leaks is passing, the water is literally just running into the bowl and away. So you'll now hopefully have had one reported already overnight, people that have recognised, they never realised that well, the water is not supposed to run in the back of your bowl all the time, because it always has. So we're educating our customers, and when we do the home water surveys, we'll fit these for free in each of the toilets in the house and leave the customers knowing that they're as water efficient from toilet use as they possibly can be.
Yeah. But you know, the other problem, Steve, what we find is mostly customers don't know their toilet's really leaking, because you're not sitting in the toilet listening to the trickle. And so an easy way to do it is the blue bill. This blue bill, if you look at it, it's a really simple thing, very neat. You put it in your system, it turns water blue. So clearly when you flush the toilet's blue. But when you're not using the toilet, if you see a trickle of blue down your pan, then you know your toilet's leaking. And then there are some simple actions to take. The other thing that we've looked at is when you look at older houses, there's quite a few in our region. The older toilets, if you remember the ones with the hand flush, I don't know if you remember those toilets. If you look at those toilets, they have quite a large cistern. And those cistern, you know, you're talking about 7 litres and all the volume of water that gets stored in this. The newer cisterns, we're talking about 4.5 litres of water. So that means when you have an older toilet, every time you flush, there's a lot more water that you're draining down your toilet. So there are two things that we offer to customers. One is, you know, we could convert their toilets, and we normally recommend a dual flush, so one with a big and a small flush in simple ways. But equally, we recognise that there are a number of customers who might not want to change, you know, their toilets. They like the setup they have in their bathroom. And so what we offer is this really neat thing, which I really like, which we call as a hippo bag. Now this hippo bag, it's very simple. All you do is you put it in your system, in the system. It holds about 1 litre of water. Now because it's holding that litre of water, when you flush your toilet, you're automatically flushing less down the toilet. So really, really simple things that, you know, automatically will make a big difference. The same thing when you go into taking a shower. So there are some really efficient aerated shower heads. Use of those ones. You could save about 25 litres a day by using some of those efficient shower heads. And equally, we recommend taking showers. You know, you could get lost in a shower in terms of how much time you're taking. Why not use this handy timer to track the amount of time? We recommend as a guide 4 minutes. It's quite neat, fits quite nicely on the tiles, looks lovely. So simple things that we could do in the bathroom. Now the other thing is we kind of work through our house and you go into the kitchen. One of the things, you know, in terms of the efficient devices that we have these days, I think we recommend an efficient dishwasher to clients. And you know, things that have worked really well for me is the fact that I hate hand washing dishes, absolutely hate hand washing dishes. But then using the dishwasher is really friendly in terms of water saving. So if you load your dishwasher really well and you use it, and you're saving water as well, so kind of a real win-win there. And then with the washing machines, we have some really good water-efficient washing machines in the market these days. Within those as well, if you choose a shorter cycle, a shorter cool cycle, you still get your clothes really clean, but you also save in water using. So really simple things are what we're kind of talking to our customers about and supporting and helping them when we go and do these home audit surveys. In terms of, you know, when they go out in their garden again, really simple things. So we've got offer of a discounted water butt on our website. Customers can get it through other sources as well. And that really helps in terms of, you know, collecting rainwater when it's raining heavily and using it when, you know, things are dry. So if the weather's dry, use that collected rainwater to water your plants or to clean your car. So all of these simple things that I've just talked about, when you add it up, what we find is that customers can save about 10% of daily water use if they change their behaviours and just kind of carry on with their daily life with these simple tools. 10% when we look at adding all of that up, what we find is effectively that could help us deliver 1/3 of the per capita consumption target. Now clearly 1/3 is not enough and we need to do a lot more, and this is where I'm going to hand over to my colleague Rose, who's going to talk about how we do the rest. Thank you.
Great, thanks Nerja. Hello, so I'm Rose Jolly and I work in our innovation team and I'm going to talk to you about metering. So in AMP7 we're looking to roll out around 500,000 metres, as Steve mentioned earlier, and that equates to around 186% compared to what we rolled out this AMP. So that clearly demonstrates there's a really big ambition on our part to focus on metering over the next AMP. So there's two key reasons for doing this. The first reason is around identifying leaks on the customer side of the boundary. So At the moment, we find around 10,000 bops or bursts on private pipes a year, and that adds up to around 10 megalitres a day. We estimate by adding 500,000 more metres to the equation that we'll find an additional 5 megalitres a day or 5,000 leaks on customer side of the boundary. The second benefit to this is the impact on the amount of water customers use. So Nurja's just mentioned that we see on average around a 10% reduction on water use when customers engage in water saving activities. We find that having a meter really helps incentivise customers to do this through saving money on their bills. So Steve's now going to demonstrate how we install the meter into the boundary box.
So I think I'll start just to make sure people can visualise if they haven't seen it before. So this is a very small version of our network. So 4-inch pipe, modern day plastic pipe. This is a ferrule strap and a ferrule. So if you're ever driving past the roadworks, if you were building a new house, for example, in our area, one of our teams would dig out, fit this onto the pipe, make a good hygienic connection, and then they provide a pipe to your house. So for the purpose of this demonstration, the pipe then disappears under the road typically, and then pops up in the footpath normally, in one of these things, which is the modern day stop tap. So some people have an old metal cover on the top, and if you're taking the kids to school, walking to the pub or the church, that's what you probably walk over the top of. It might be different shapes and sizes, but broadly, hopefully that's what you'd see, nice and flush and safe in the footway. What's inside? It's not that exciting unless you're like me. I think it's quite a brilliant invention, because when you think of an old brick chamber that would be built in the footway with a brass stop tap at the bottom, lead into one side, copper out the other, and you look at the service that we provide now, our teams, you'll see some techniques next door, they can install these really, really quickly. So at the bottom there you'll see, hopefully you can see there's a bung basically which you remove, and that literally screws out. You screw that out and you screw one of these in currently. So this is a water meter, and previously most water companies would fit this water meter inside the property, so it'd be under the kitchen sink typically, and it would be obviously within the blue pipe that comes into your house as it is now, and then goes off into the rest. It's amazing how many people don't know where their internal stop tap is. So if you don't, please have a look when you get home. It's really important, because the older stop taps in the road don't always work, and people don't always treat them with care. And if you were to have a problem in your house, it's simple, but if you can't turn that off, you can't stop the flow of water. So why do we fit it at the boundary? Well, if you can imagine this blue pipe from the meter then disappears up your long winding driveway wherever you live, and then it pops into the house. If there's a leak on that pipe anywhere, unless it shows itself or you don't get water upstairs, how would you ever know? And as Rose said, we already find 10,000 of these a year. So it's really, really important for us to be able to quantify. Some of them are very small leaks, and you'll see how we deal with some leaks again next door. So in fitting the meter here, we can then do what we call a simple internal check. If the meter's spinning round outside the property, and you turn that valve off, if the meter's still going round, you know obviously there's an escape of water between here and there. So it really is quite simple. And then the customers can decide what it is they want to do about it, because the customer of course owns the pipe between the boundary box and their property. And we offer loads of help and advice and assistance to be able to get that done. But the reality is, any advice I would give to people is you want a modern day pipe. It's the best from a hygiene perspective, it's the best from a health perspective. If I moved into property with a lead pipe, I would strongly recommend anybody to replace it with a modern day, best in class that you could get. So meters are relatively cheap, at the moment. This is around £35 to buy for the standard meter, where the installation cost of mobilising the team and digging in a highway can be a lot more expensive. Of course, we are focusing on the efficiency, and again next door you'll see how much productivity gains we've been able to get. But one of the other bits of natty tech on here is this is called a cyber on the top, and basically rather than having to open the boundary box and read the meter, you can drive past. At the moment, the technology, you can drive past and pick the meter reading up. So it's really, really efficient for us. But the main thing for us from efficiency point going forward is that once this receptacle is fitted, I always say, let's imagine this is the Betamax video equivalent of meters today. In 5 years' time, when the modern Blu-ray equivalent or streaming comes out, you haven't got to dig the road up. You haven't got to go to that expense. You can screw this out, screw the new one in. You don't have to disturb the customer, or the customer doesn't necessarily have to be at home. So we are really future-proofing, I believe, to be able to put those pieces of new technology as and when they come. So the 500,000 that we are going to fit in the AMP, we're not buying a 500,000 and fitting the same meter. We're going to buy what we need along the way, and then I believe we'll pick the right product, the right technology for the customers going forward. So if you haven't got a meter, strongly recommend one wherever you live.
Great, thanks Steve. So you've just heard that there's 2 key benefits to our customers for having a meter. The first is that it's much easier for them to identify if they've got a leak on their side of the boundary. And secondly, it really helps and incentivises them to save money on their bill. Thank you. I'll pass back to Steve now.
Thanks, Rose. So in overall terms then, from a water management perspective, we have got a global water scarcity problem. We know we have one nationally. You've already seen how we're going to look to influence that nationally and help other water companies out, but equally be able to help ourselves. And then when it comes down to locally, we're using our great track record, and we're using our foresight, if you like, from AMP6 to be able to now confidently deliver these targets in AMP7. The advantage, I guess, for you guys is you'll be able to see our progress against those, because on a yearly basis you'll see our progress, and I'm supremely confident you'll see us knock those numbers down year on year to hit the target. So thank you very much for your attention.
Good afternoon everyone, I'm Stuart Howell, I'm the Head of Finance for Operations here at Severn Trent, and welcome to our network zone. So you've heard Sarah talk about 4 key ODIs within water management, and we're going to be talking about one of those here, which is leakage. So we've got an ambitious 15% or 62 megalitre per day target in AMP7, and around 50 megalitres of that will be from direct improvements onto network, with the remainder from reducing customer leaks on their private pipes. So we're going to hone in on 2 key areas in this section. One is fast to find. So fast to find means finding leaks earlier and faster, so hopefully when they're smaller before customers report them. And then once those leaks have been found, fix them as quickly as possible. So we've made some enormous progress in the last few years in this area, and technology has been a huge enabler. So for those of you that were at Bruntingthorpe 2 years ago, we've invested in much of the technology we'd have shared then, and the team will share some of that shortly. So leakage reduction is clearly beneficial from a climate perspective, but it also presents some wider business opportunities for Severn Trent. So firstly, we estimate that we'll save around £2 million per annum just from not having to treat and distribute water that would have otherwise leaked through pipes, so good news. I guess with confidence in our performance comes an opportunity to outperform an ODI. So we've got a £325,000 reward for each megalitre behind our targets. And I guess leakage is one of those totemic issues for us. So reducing our leakage by 15% can only improve our reputation with both customers and wider society. So I'm going to hand over to the team now. So firstly, Adam's going to talk about some exciting plans that we've put in place for Fast to Find, before Sophie picks up the fix area. And then Matt's going to share some really exciting innovation that could be absolutely game-changing for us in AMP7 and beyond. So over to Adam.
Thank you. Afternoon all. So I'm Adam Perkins and I'm the operational lead for leakage, and today I'm going to talk to you about our Fast to Find. So our Fast to Find programme is with the aim of supporting our 15% leakage reduction challenge, and we've been working on a people and technology plan over the last 2 years to gear ourselves up ready for that challenge. We know to achieve our 15% we're going to have to be aware of leaks 20% sooner than we are today, and then when we're aware of them, find them 20% quicker. So that's our challenge. And our challenge is bringing together people and technology, and we call that our leakage operating model, or what we like to call is LOM. And our LOM programme over the last year or so has been an insourcing strategy, bringing in 116 what we call water network technicians. These water network technicians are patch owners, so they look after their own areas. We've carved our company up into 116 areas, and each of them have ownership and accountability for delivering the leakage performance in them areas. So it's really clear what they need to achieve. And over time, they've built up some great knowledge of how that network works as they live and work in these areas day by day. So to bring that to life, I'm going to hand you over to Tom and Ryan, 2 water network techs who work here in this very area, to bring that to life for you.
Hi there, so I'm Tom. I work for Leakage in Warwickshire. So since the new leakage operating model has gone live, it's really given our guys the ability to have a lot more focus, flexibility and ownership at working in their district metered areas. So here we are sat in the city centre, surrounded by us is the ring road, and to give you an idea, inside that ring road is actually one district metered area. So how a district metered area works, if you'd like to have a look at the rig, the water comes into the network and it passes through a sluice valve. So these are just like big taps on our water mains. And then that would go through then our meter. So this is where we collate all our data so we know exactly what's happening in the district metered area. Down our water mains, into our service pipes which feed your homes, and you have your external stop taps. And our other assets at the end of the mains like our fire hydrants. So the city centre here has always had a high level of leakage, and historically it's always been a really difficult place to work with the amount of students, nightclubs, etc. stuff like that we have. So we had to put a plan together to how we were going to tackle this, so I'll pass you over to Ryan.
Hello everyone, I'm a water network technician here in Warwickshire, and the DMA that Tom's just been describing to you is in my patch, so I actually own this DMA that we're in currently. What LOM helps me do is change my shift patterns to what's needed to specific areas. So as you can imagine, the city centre in the day, it's just so busy, you can't do it, so all of my work has to be done at night. What we've also got is these permanent loggers here, so that's new technology, and that helps me give me specific areas to target to try and find the leaks, rather than going into the area quite blind. It also helps me find the leaks a lot quicker than traditional methods. When we got the burst mains that I found in this area repaired, which are now repaired, this area is now its lowest levels of leakage it's ever been. And also going forward, these loggers will help me sustain that level of leakage as well. Thank you.
Perfect, perfect. So hopefully a little glimpse there into what it's like working in our leakage operating model. And like you heard the guys saying, this ownership and accountability is driving a step change in our performance. You also heard them talk about technology helping them, new tools in the toolkit. So it's not just our people, it's about giving them the right equipment to deliver their job and deliver our 15%. So if you were here 2 years ago in Bruntingthorpe, you would have seen a lot. We talked about acoustic loggers and about loggers, I think they were attached to the ceiling actually at the time. And we are investing £10 million in 36,000 of these. And essentially these are spread every 150 metres on our network, listening out for leaks all the time. We've decided to put them on the 15% of our most reactive network, which isn't this shiny stuff over here. It's more like this, more of our ageing infrastructure, our cast iron mains that have high burst rate and high consequence of failure when they do burst. So where we get the best value for money is putting it on this 15%. So what that will help us do is find leaks underground long before they become visible, long before they impact customers' lives, and also give us the added benefit of improving our resource efficiency of finding that leak by around 30% in the areas where we've got these. So I guess how do they work? So a really simple way is that, like the guys said, between 2 and 4 a.m. in the morning is when the network's at its quietest, when we have the least demand and we have the least background noise from, I guess, people that you see here today. So what that does is it takes a sound file between at 2 a.m., 3 a.m. and 4 a.m. And if it hears a signature that it believes is a leak and it hears a consecutive signature 3 times during that night, it would alarm out, and it will alarm and send that alarm into our office teams and then pass that on to our field teams first thing in the morning. So instead of having to look at a whole area, say this DMA may be 15 kilometres of mains network, we're pinpointing an issue down to 150 metres. So for someone like Tom or Ryan, they're not going to be spending all day walking around this area looking for that issue. They're going to be going very to the point of where we know the issue is. And that's obviously created this step change performance that we've seen in the amount of leaks that we're finding before the customer knows of the problem. So we've seen that increase from 35% to 50%. So that means that we're now finding 50% of our leaks non-visibly underground before you even see, before the customers have a chance to report them, before customers' supply may be interrupted if it does fail catastrophically. And also that gives us confidence that we're finding leaks much sooner in the journey and therefore leaking less water. So these are great on metallic networks, on pipes, old metal pipes that we've got on our network. But we know as we put more new networks in the ground, that's likely to be plastic, and therefore acoustic technology isn't the best solution. So that's where our dynamic pressure loggers come in. So we've invested a further £4 million in 6,000 pressure loggers. This will cover again 15% of our plastic network. And essentially it's looking for pressure changes in the DMAs that may indicate that something's not quite right. We know what our predictive pressures are on a day-by-day basis, hour by basis. If we know that something's not quite right, we would then start to send these guys into these areas to investigate. Now, they're not like the same as the acoustics that may give you a 150-metre area to investigate, but what they do is give us segments within a DMA, so we can carve them up and alert the guys to a particular segment of the network that we believe the issue is in. Again, further improving the time to find that issue and also getting on top of that issue before it affects our customers. So you've seen some great work in terms of fast to find, but it means nothing to us unless we fix it. So I'm now going to hand it over to Sophie, who's going to talk about some of our fast to fix initiatives.
Thanks, Adam. Some really great fast to find solutions. I'm Sophie, and I'm from our customer operations frontline team in Leicestershire, and I'm going to talk to you about 2 fast fix solutions. So the first one you can see outside to my left, so this is our vacuum excavator. This is essentially an industrial hoover that takes the spoil out of the excavations for us. This is a really great example of where Severn Trent don't always have to lead in innovation. We're also sometimes really fast followers. We saw this idea presented by another water company, and we cracked on with the idea while they thought about it. So the vacuum excavator helps us to excavate and fix leaks much quicker, therefore reducing disruption to our customers, reducing our costs through increased productivity of our repair and maintenance teams, and reducing the overall volume of leakage on the network. In areas where this has been deployed and is used frequently, we've seen a 30 to 50% increase in the number of jobs completed per day. And there's also significant health and safety benefits. So we want the risk to our employees in their jobs every day to be as minimal as possible. So the key health and safety areas are around manual handling. So for excavations that would traditionally have been hand dug, we can use the vacuum excavator, and that minimises that risk. It also reduces the risk of cable strikes or striking pipes within the excavation as well. One of the long-term benefits of vacuum excavation is around reducing our carbon footprint. So it presents the opportunity to actually create smaller excavations, therefore using less materials like tarmac and also using less fuel to transport those materials. So another really exciting innovation that I want to talk to you about that's been developed in-house at Severn Trent is the seeker leak. And this is it. So this is essentially a putty that can be inserted into the customer's supply pipe, follows the flow of the water, finds the leak and forms a seal to actually cure that leak. So this demonstrates that even those smallest leaks we're targeting to make sure we're saving every drop of water that we can. So this was an idea that came out of the 2017 Challenge Cup campaign. This is an annual campaign that Severn Trent runs for all its employees to submit and pitch their ideas to drive efficiency within Severn Trent. And if you're at Bruntingthorpe 2 years ago, you remember that this idea was in its very early stages of development. But now, 2 years on, we're halfway through a knowledge transfer partnership with Manchester Metropolitan University to take this idea to the next level and develop something that's unique to Severn Trent and the ways and means to get this into the customer's supply pipe. So this is a really great example of where Severn Trent has taken an idea from a frontline member of staff, added some technical expertise through university, and also reduced the overall costs of the project through external funding to produce something that's potentially going to be a transformational, game-changing repair technique. How cool is that? So you're actually going to see a live demonstration of this today, so I'm going to hand you over to Callum. For those of you who can't see from where you're sitting, it will also be on my screen to the right as well.
So we have the same kind of pipes that you're likely to see underneath your driveway. We have this putty. We insert it into the customer supply pipe, and without digging, we are able to repair leaks.
There's an element of jeopardy to that every time. So live demos don't always go well, do they? But 10 out of 10 so far, so things are looking good. Thank you, Callum and Sophie. So my name's Matt. I am the Water Innovation Lead here at Severn Trent, and I'm going to talk to you about a couple of other things that we're looking at that might be our next vacuum excavator or our next seeker leak. So robots, pretty cool, eh? So Severn Trent is really interested in what robotics might mean to the water industry in the future. We're working as part of the 2065 programme, which is a academics programme, led programme, so a number of universities across the UK, Leeds and Sheffield being two of them, on what robots we might look like in order to put into our water networks. So there's three key elements of the PipeBots programme. The first one is mapping. So how do we put small robots into our pipes so we can map the whole of our system and know where all of our pipes are. So that's really important to us. We have drawings and we know roughly where most of them are, but to exactly know to the inch where they all are would be really interesting for us. So the next one is, could these robots also take a view of how good those pipes are performing when they're on the inside? So some condition assessment, helping us to understand where the weakest parts of those pipes might be, and which bits need replacing and which bits are actually okay and have a longer life left. And the third thing is repairs. So wouldn't it be really good if they could take a piece of the putty maybe that's Callum's developed and put those into some of those weaker holes, some of those small leaks, saving us water, and repair them from the inside without us having to excavate at all, and get those small leaks before they turn into big leaks and catastrophic failures. So that would be really good for us. So unfortunately, our robots don't exactly look like the ones that you saw on the screen. They look a little bit more like this. So this is an actual robot that's been in a sewer pipe and developed up in Leeds, and that's more like what it does. Okay, so robots is one thing. So another thing I'd like to talk about, the second thing, is fibre. So how do we use fibre optic cables to help us understand our water main network better? So Severn Trent had a UK first. So on the 5th of February this year, we put 750 metres of fibre optic cable into a water main in Leicestershire. And we then simulated some leaks across that main, because obviously we hadn't got any on that main. So we had to simulate some flow and some leaks, and we really understood down to the millimetre of where those leaks were simulated. So if you think about what Adam was talking about earlier in terms of pressure and flow loggers and being able to pinpoint down to maybe 150 metres in length, if we think about fibre would give us probably tens of thousands of pressure and flow loggers along that length. And rather than sending Tom and Ryan to go and have a look in this area or along this pipe, they'd be going to have a look at this place and tell us what's going on in this area. So it would help us to become much more efficient in the way that we find the problems and much better at the way that we deliver the solution to those problems. So you can imagine digging holes, a bit, that Sophie talked about earlier, it's quite a laborious task. We want to dig smaller holes, we want to dig less holes. So being able to pinpoint those problems within an inch and being able to dig right on top of them opens up a whole load of opportunities for us in the way that we repair them. So think of a 2065 and the robotics program, what our water and wastewater networks might look in 2065. Armies of robots scurrying around, mapping our network, finding the problems, understanding where our pipes are and fixing them. Fibre optic cables on some strategic assets that are really giving us loads of data so we can pinpoint any problems that we've got down to the minute degree. Really feels like we're taking care of one of life's essentials. Reducing the amount of leakage that we have, reducing every drop that we can possibly find, really going after that abstraction so we don't have to take as much from the environment and reducing our carbon footprint. I think I'm going to hand over to Sarah to wrap up.
We're almost there. You'll be pleased to know. I'm just so proud. Thank you, huge thank you to the whole team who are out day in, day out, round the clock, making sure that we really protect every drop. And hopefully you've got a little bit of the passion that we do of carbon is a real important part of the whole climate change agenda, but water is a critical part, and we are absolutely passionate with all our people to make sure that we do our bit to ensure water security.